solenoid with soft iron core. It's a sending wire made of soft iron. It's a winding wire, insulated. We have removed insulation at the ends, round about 500 tons. We can use as electromagnet also. Now we are performing the demonstration of electromagnetic induction. So whenever the flux link with the coil changes, EMF is induced and so current. The induced current opposes the vary cause. See the indicator. Initially flux increases. Now we are removing this. Increases. It reduces to 0. Induced current is produced in such a way that it opposes the vary cause. This. If it moves slowly, the flux is less. See, the indicator vibrates in either direction from 0. Okay. Electromagnetic induction. We have studied the magnetic effect of electric current. That is, current carrying wire produce magnetic field. So the reverse question is that, can we create electric field using magnetic field? The solution is given by Michael Faraday. It is called Faraday's law for electromagnetic induction. Suppose this one is good conducting wire coil. We have connected galvanometer across two ends. This one is strong bar magnet. This one is we have fixed. It will not tend to move. And we are bringing bar magnets with high speed towards the coil. So the magnetic flux linked with the coil is changing. So EMF is generated. This is the law. Whenever magnetic flux linked with the coil changes, EMF is generated in the coil. And it is given by average EMF is minus delta phi by delta t. Delta phi stands for change in magnetic flux. Delta t is time interval for that change. Here the minus sign is due to Lenz's law. Suppose magnet north pole here and it is moving towards the coil. So magnetic flux linked with the coil increases. So EMF is generated and the current direction in this coil is this way. So this end behaves as north pole and this one is south pole. Magnetic field produced due to this current opposes the motion of the magnet every time. It should be, it must be, due to law of conservation of energy. So instantaneous EMF is what? Minus limit delta t tends to 0, delta phi by delta t, that is minus d phi by dt. After this position attained, suppose the magnet becomes stationary. We are making stationary. At that time, no flux is changing, so EMF is not. And after that, this one is north pole, this one is south pole. We are moving away from this. At that time, in that time interval, current, induced current is this way. So this end behaves as south pole and magnet is moving this way. So it attracts the magnet. That is, it opposes the magnet. Every time it opposes the motion of the magnet. Lenz's law says that induced EMF or induced current is produced in such a way that the magnetic field produced due to it opposes the vary cause. Now this is motional EMF. This one is U-shaped wire frame and this one is resting like that. In this region, magnetic field is going into the plane of board normally. This one is having resistance R, and this wire remaining in contact, we are moving with velocity V. So by the time area of the coil changing, here area increases. Even then the magnetic field is uniform, the flux linked with the coil increases because of area increases. Suppose at intermediate situation we have taken photograph. At that time the distance of this wire from this end is x. At that instant the magnetic flux linked with the loop is B dot A, that is BA cos 0. But what is a length into breadth? It is x. Cos 0 is 1. So magnetic flux phi is BLX. So EMF is negative of the time rate of change of magnetic flux minus divided by dt. So minus dt of BLX. So BL is constant, dx by dt. The rate of change of x is nothing but the velocity of this rod. So EMF is given by minus BLV. Here V, B and L all are mutually perpendicular. Using this formula, consider a metal wheel is rotating in this plane and magnetic field going to the plane of board, uniform magnetic field. These are the spokes. So due to this formula, EMF is generated between the axle and rim. We will apply this, but here each and every rod element have different velocity, different speed. So if we consider a spoke element of width dr at a distance of r unit, very small length, so EMF generated between these two ends is very small, negligible, say dE, and it is given by minus BLV, but L is replaced by dr, length of spoke element. V is replaced by omega r, because it is rotating with angular speed omega. So D is minus B omega r dr. But all such microscopical elements behave as batteries of microscopic small EMF are in series connection. So net EMF generated between the axle and rim is given by E equal to integral 0 to r dE, integral 0 to r minus B omega r dr, minus B omega r square by 2, replacing lower limit, upper limit, etc. We have minus B omega r square by 2. Minus sign is here, also minus sign is due to Lenz law. Here we are moving this wire in this direction with velocity v. So EMF is generated in the coil, in the loop. But in which direction current is moving? Whether it is anti-clockwise or clockwise. It must be anti-clockwise because of, we know that magnetic force acting on current element kept in magnetic field is given by dF equal to IDL cross B. But here magnetic field is uniform, so we can consider IL cross B. IL this, IL is this, B is this. So IL cross B, force is this direction, velocity in this direction. So it opposes the motion. So current must be in this direction. And if you want to maintain velocity constant, we have to apply exactly equal to force ILB this way. ILB acting this way, agent applies force this way. So we can maintain constant velocity. What about electrical power in this coil? Electrical power is EI, it is minus BLVI, minus BLV. I is what? E by R, EMF upon resistance. So minus BLV by R, B square L square V square by R. Where it come from? So it is come from mechanical power, and we know that mechanical power is nothing but the rate of doing work, dW by dt. It is F dot dr by dt. So F dot V, it is the force applied by agent. It is exactly equal to by magnitude ILB. So ILBV, this is same. Here also I is replaced by E by R. E is BLV by R by magnitude. Add LBV, so B square L square B square by R. So mechanical power equal to electrical power. Whatever mechanical power generated, it is converted into electrical power. Now self-inductance of the coil. Suppose this is a copper wire coil. This one is resistance R. This one is battery having some EMF E. At the time of switch on, current passing through this. So it behaves like a magnet. So magnetic flux linked with this coil. For each turn say phi, so total flux is n phi, and common sense says that n phi is directly proportional to I. So if you want to remove the sign of variation, we have to put some constant. It is capital L, n phi equal to Li. L is called self-inductance of the coil. N phi upon I, that is magnetic flux per unit current, which is called, the unit is called Weber per ampere. It is called Henry in memory of Henry. Self-inductance of the coil. Suppose by somehow we are continuously changing the EMF of the source. So current also variable. Current is also variable. So flux changes. And so EMF generated in the coil, which opposes the actual source. If current increasing, it opposes the increase of current. So E is minus d dt of n phi, but n phi is Li. So E is minus d dt of Li, but L is constant for given coil. So E equal to minus L di by dt. Subjecting L, minus E upon di by dt. This term is called self-inductance of the coil. And the definition from this term, self-induced EMF generated in the coil per unit rate of change of current is called self-inductance of the coil, and the coil is called inductor. The unit for self-inductance is volt into second per ampere. It is also called Henry.